Okay, this will be homework number 31, so I'll try to do a couple of these here. This is number 52. And we wanted the integral of the cosine of the fourth of x minus the sine to the fourth of x dx. And it looks like this is like a perfect square, and this is a perfect square in terms of x, in terms of cosine squared of x. So I can factor this. This is like a squared minus b squared is a plus b times a minus b. So I'll factor it like that, and you'll see what happens. Cosine squared of x plus the sine squared of x times the cosine squared of x minus the sine squared of x dx. But this is just our old favorite Pythagorean identity, so this is just going to be 1. And then this happens to be, which we derived earlier, this is the cosine of 2x. That's the cosine of 2x, the double angle formula that we derived, I think, back in problem number 47 or 49, one of those two problems we derived that actually. So you've got that at your pleasure. So we've got the cosine of 2x dx. And then that's what we need to integrate. So we'll let u equal 2x. So we've got the integral of the cosine of u dx. And then we got to match these variables up. So we'll let du dx equal 2 dx dx. All right, and then we have du equals 2 dx. So du over 2 equals dx. And I've got a match here, so now I have the integral of cosine of u times du over 2. Bring that 2 out, so it's 1/2. The integral of the cosine of u du. And what's the integral of the cosine of u du? That's just the sine, right? So we've got 1/2 the sine of u plus c, which is just 1/2 the sine of u plus c. And then we can finally do our substitution back in. So 1/2, and what's u? 2x. So there we go. So that's number 52. Let's take a look at number 54. Try to get this done also. Leave this on here for you if you want to see that, just in case you need to write it down. So it's pretty straightforward. Okay, let's take a look at 54. And this is going to be the integral from 0 to 1 of r times the square root of 1 minus r squared dr. And I don't like this form, so this is a radical form, so I'll write this as the integral from 0 to 1 of 1 minus r squared to the 1/2 times r dr. Now this is going to work out for you to the end, because you can see the derivative of 1 is 0 and the derivative of minus 2r squared, of minus r squared is negative 2r. So I've got the r part. That's the hard part to fabricate. I can get the number easy. Okay, so I'm going to let u equal 1 minus r squared. So I can substitute this in. So I've got the integral from, now I got to change my variables, don't I? Just forgot to do that. Okay, so u is 1 minus r squared, so 1 minus 0 squared is 1. Okay? And then 1 minus 1 squared is 0. So I kind of flips these things around, but we'll fix it in just a second. but this is going to be u to the 1/2 times r dr. Okay, so we can fix this, and we can also fix this. Now remember, we cannot integrate to the left. We got to from right to left. We got to integrate from left to right. So we've got to change this. So we just make it a minus. Go from 0 to 1. That takes care of that. And then this is going to be u to the 1/2, but we've got u's and r's, so we got to fix this over here. So we find out that du dr equals 0, negative 2r dr, which is just 1. So we have du equals negative 2r, and then I'll put that dr over here, dr. And then I've got just the r dr, so I'll divide both sides by negative 2, so I get r dr equals du over negative 2, so I'll make that substitution. So that's going to be my du over negative 2. Is that okay? And then I'll bring this out in front. Now a negative times a negative is a positive, so that kind of works out. Okay, so we have a positive 1/2, okay, times the integral from 0 to 1 of u to the 1/2 du. And we're ready to integrate that. Okay, so we add 1. So it's going to be 1/2. And that's going to be evaluated. So if I add 1 to that, that's going to be u to the 3/2 divided by 3/2 or times 2/3. We'll just write it out, divided by 3/2. And we're going to go from 0 to 1. So that's going to be the same thing as 1/2, and then we're going to go this to 2/3. U to the 3/2 evaluated from 0 to 1. I can simplify this a little bit and get my work done. So this is going to end up being 1/3 u to the 3/2. And again, we'll use the second fundamental theorem of calculus, so it's be f of b minus f of a, or evaluating it from 0 to 1. If I substitute this in, I've got, at 1, I've got 1/3 times 1 to the 3/2 minus 1/3 times 0 to the 3/2. And that's just going to be 1/3 minus 0, which is 1/3. Okay, so that wasn't too bad.